Hello everyone, welcome to my session on build generative AI application with Google Database and Cloud Runtime. Yeah, so the agenda for this talk is simple. We will cover the overview of Gen AI, then components of Gen AI, and we'll do a demo. Then finally talk about the possible next steps. So once upon a time, a long time ago, human created fire. After that, human created wheels. Then finally, human created application and data. So, and in like 2 years back, this guy came in, Gen AI. And Gen AI has been a buzzword, and it's almost illegal to have a tech talk in 2024 and not talk about Gen AI. So today we'll also talk about Gen AI. And the fantastic thing about this Gen AI is the experience that it creates for me and you. So Gen AI is opening a whole lot of experiences from content creation. So when we talk about content creation, we talk about it from the part of using prompts to talk to Gen AI. So you can use create with your prompts, use a lot of prompts to generate different things from Gen AI. So another thing that Gen AI offers is the domain-based conversation. So there are some times where you come into maybe a chat box and you are like wondering that it would be fantastic that this chat box remembers my past history so that I can just come off from where you left previously. So that's one of the functions of the Gen AI. And the last one is semantic search. So semantic search is different from keyword search. Keyword search is like I have a keyword and I go to a website. I can put the keyword on that particular website and it returns information related to that keyword. But for semantic search is like, so let's say I have a question that, do you like this website? So when I ask you, do you like this website? And you reply that yes, I like it. So when I ask a follow-up question that, what do you like about it? So when I say that is IT, in that case, it refers to what? It refers to the website I was talking about previously. So that's the part that semantic search comes to. And with Gen AI now, we can also, we have that capability. So nearly 80% of enterprise will have Gen AI applications. And the interesting thing is that it's just like, we are just like in Gen AI for like 2 years when it was widely available. And there's a projection that by 2026, it will move up to like 80%. So that's like 15 times the speed that Gen AI is having now. That's like 15 times the use cases that Gen AI is having now. So, and when we talk about this type of projection, it's some people that will power that projections. So if you look at the review of the labor statistics, it tells us that there are like 10 times more developers than data practitioners. So that's to tell us that most of all these changes that we'll be seeing in Gen AI would actually be done by you or the developers, not necessarily the data practitioners. They will be the one building the underlying model, but in integrating those models to your application, in integrating those models to existing databases, it will more be the developer work. So, and like you all could project, so with building new things, it comes with a lot of hurdles. And these are some of the hurdles that customers have reported when we were trying to integrate Gen AI into the application. One of them is skill gap. So 58% peak skill gap as the issue for complexity. But if you look at it, when you also solve the issue of skill gap, you'll also still notice that there's still another hurdle. So another hurdle is data availability and quality. So in this case, we have the data engineering part, the data cleansing part, the data formatting part, and the quality of the data. You know that when you have good quality data, it leads to good quality models. And also, third of the company also mentioned cybersecurity and security to be an hurdle. So this is more of just understanding the vulnerability opening that Gen AI can offer. But moving fast. So in the long run, what this is just telling us that how we build application previously would not necessarily be how we are building application in this Gen AI era. So we have to build applications in a different way. And these are some of the ways we can empower ourselves to build applications in this Gen AI era. So the first thing I'm going to talk about are the 3 P's of successful AI application building. And the first P is the proximity. So you have to make sure that your application and your database, they are close together. So when they are close together, it saves you a lot of latency issues. It saves you a lot of ingress issues or egress issues. So when they are closely related together, it saves you a whole lot of time, and it helps you to develop your application faster. So another one is platform. So if you have a fully integrated platforms for your data, for your model, for your deployment, so it also saves a lot of time, and it also helps you scale faster. So and the last part is productivity. So you can also use Gen AI applications to boost your productivity, like code review, unit testing, and a whole lot of things that other speakers are also talking about. So when we look at the Google Cloud Gemini, so looking at how we can use Gemini to boost our productivity as a developer. So you can see there are some inner loops. The inner loops contains those things that are generally related to us, from the code generation to code summarization to unit testing and the others that are there. And we also have the outer loop. So the outer loop means how Gen AI application can also help our work better, but not like directly connected to us, such as vulnerability scanning, streamline gist process, and a whole lot of others. So now we would also continue from the history I was saying before, that human invented fire, human invented news, and now we have the application and database. So how can we plug in Gen AI into application and database? So now we are at this stage. We have the application, we have the database, and we are trying to shove in Gen AI, which are the foundational models for our LLM, in between the application layer and the database layer. So there are different ways whereby you can get this ML models. So it's either you build a model or you consume a model. So if you are building a model, you can use Vertex AI, that's what people have talked about, and you can also use AutoML. In this case, the model is already created for us. You just need to go there, plug in and play. If you also want to go a step down, you can go to GKE and have your model, train them on your container, that's your GKE, and you can also work on them. If you also want to go a step lower, you can then purchase CPUs, purchase GPUs, purchase CPUs, and build your model on those GPUs, CPUs, and CPUs, and also work on your model. Or you can just consume your model by using AutoML, Vision AI, and the rest are there. So now that we've explained how the models can come about, so we now ask ourselves a question: is this LLM, is it good enough for us to just plug in and play directly at this now? So the honest answer is that it is not good enough yet. So with LLMs typically have some issues, and I like to think of it as using. The first one is there's a lack of domain knowledge with LLMs. So there's a lack of domain knowledge. There's also hallucination. So you could just say what it thinks it is, and not necessarily what you're asking. And there's also a final issue of cut-off training data. So LLMs typically have those 3 issues: domain knowledge, then the hallucination, and the cut-off training data. That's not going to be able to answer parts the time that it was trained with. So having our business data in line with our database helps us to build the gap that LLM still has to fill. So in this case now, we are trying to augment our business data with our foundational models and connect it to our Gemini apps. So one way whereby we can bring in the business data into our application, it's in different formats. You can use prompt engineering. So a lot of people have talked about prompt and how to fine-tune your prompt. I'm not really going to talk about that. But prompt is also necessary because prompt is like a must-have for your LLMs. Then we have the fine-tuning model. So fine-tuning is more of like you have your existing LLMs, you also have your existing data, you now fine-tune them and tune them together. But that could also be expensive. That could also have a cut-off time issue, because it's not necessarily integrated together. So it's more like a point in time result at that particular time. But the best of them, or more of like maybe a combination between both, it would be the Retrieval Augmented Generation. So which is more of like you have your database which contains the domain data, and you have your LLMs So when the prompt comes in, it goes through. When the prompt comes in, it goes through. It goes to the database. It now picks out. So let me use this fact to explain it. So let's say you have a question. When the question comes in, it goes to the database, and the database is done in a way whereby it has some vector embeddings. So you convert your questions into vector embeddings. Then it goes into the database. When it goes into the database is saved in a way whereby similar things are saved together. So we are talking about vector embeddings. So they were like saved together. And it's going to retrieve the top K chunks. So top K chunks means like, just like we have limited memory and we have limited capacity also. If you tell me 10 things.
Can I ask you a question? Before you get to that, when you're working with the data, do you need to do it at once before you get to this point?
So we are just talking about the query that the user gives an application. So when let's say I'm asking a question that, what is our return policy? If you ask me, what is my return policy to Gemini today, it's just going to tell us that the average company return policy is maybe 30 days.
So you get generic.
Yeah, generic, but that's not specific to your own business. So bringing in RAG, which is Retrieval Augmented Generation, is more of like your database, which contains your domain data. It's in there. So it takes the user query and retrieves from your database similar query to that query that the user input.
So it's customizing for your
business, of course. You are connecting your database to that. So then it returns the top K chunks, which are like the results that are similar to the query that the user sent. And after that, it now takes that into your LLM. So your LLM can now give you like a tailored response into what you want. So I don't really have much time. So I've explained this part with this question. More like you're asking what is the return policy. It tells you that the return policy is on the average of 60 days. So let's go into the major architecture. So typically how LLM works with database, we have the app server. So for this demo, I'm going to be using Cloud. We also have the vector database. So vector database, more often than not, means any database that has vector embedding in them. So CloudSQL does that, RDB does that. If you're also using MySQL, SQL Server or PostgreSQL, so they are highly compatible with CloudSQL, so you can also solve that information. And if you have a whole lot of large data, you can use Spanner. Spanner is also vector embedding compliant. And if you have large data, maybe the most amount of data set, you can also connect it to BigQuery. So BigQuery is also connected to, BigQuery also has the function of vector embedding in there. So we have the data ingestion data. We have after the data is ingested from the data query, it takes it to the serving subsystem. So the serving subsystem is like the application. And after the applications, it takes it over to the quality subsystem. So the quality subsystem is like it's checking the results. If you use AI Studio today, there are some settings that you can use, like maybe you don't want pornographic results, you don't want dangerous content. So all those things comes into this quality evaluation system. So it checks the quality of the response that I want to give, and it makes sure it is safe for the user before it now returns. So this is the architecture overview, and this is just like the first principle. So if I show you, this is the more detailed architecture overview, and I'm just going to pick each and I said,
you said something about the database. So is the database encrypted with part 2?
Is the database encrypted because it's used?
I know you get those basics.
Okay, so I mean that the database is yours, so you are the owner. So the database has to have vector embedding enabled in it before it could work for retrieval augmented search. So it's just like when I say what is my company policy on the phone. The database is not able to understand what the phone means, what company policy means. So the vector embedding converts that query into numeric computation. So and your data that are inside the database, they are in some numeric computation. So the numeric computation that equates the question are going to be the one that is going to be retrieved in the top K chunks that was explained previously. So that's how it works. The serving subsystem. So the serving subsystem, if you take a look at it, I'm not going to spend a little time here. So when the user application comes in, it goes through the front end part, And when it goes to the front-end part, it comes to the database, which was what was asking for. And when it gets the embeddings that are related to it, it comes back here. And it now brings the inference. So the inference is in this part. So it takes the result from the vector embeddings, which is what the database gives us, and it also takes the query. It sends both of them to the LLM that we are using, which is Vertex AI in this case. And after that, it also goes back. So if you want to save the logs of the result, you can save the log to cloud logging and cloud install. If you also want to analyze the result that the users are asking, you can get that from BigQuery. And finally, it now takes the result back to the responsible AI checks, which is where it checks that is this result safe, is this safe, is it a dangerous content or other safety settings. And finally, it goes back to the front end now. So it's an evaluation system. And like I mentioned, if you are not doing production stuff, you don't really need this quality evaluation stuff. But if it's something that you are serving to external users, you don't want to serve business to them. So you want to make sure that what you have is actually top part. So that is why you can have this quality evaluation system in between the process. No question. So thank you very much for having me.